Okay. So see this particular math where there's like if you would have seen like various masjids are designed in this manner. Like say there is a cylindrical shape at the bottom, and there like a tomb shape we have a semicircle. Okay. So now the radius, sorry, not semicircle, hemisphere, which is the half of a sphere. Okay, it's cut into half. So what would be the volume of a hemisphere? Can you tell me?
Bottom of a hemisphere. It's
No, no,
area.
just volume of the hemisphere. What is the volume?
Volume.
Yes.
4/3 pi r squared over 2.
Not pi r squared, pi r cube. Okay, pi r
Pi r
cube.
cube, sorry.
Yes. All right, over 2. Yes, absolutely correct. You have to divide by 2. And in case of this cylinder, okay, so the cylinder's height is known, and as you can understand, okay. Now tell me, what is the radius of the cylinder? Let's see. What is the radius of the
15.
15? Why is it 15? Can you tell me?
Because the radius in a sphere is pretty much all around the degrees of the actual sphere. It's the
Yes.
same length everywhere.
Okay. If I'll just clear it a little bit even more, see, whenever we are constructing a sphere, okay. Okay. So the construction of a sphere, this is the point, okay. Now the radius would be like 15, okay. Now after I have rotated in this axis and formed the sphere, actually it's the part of the same circle, okay. So it will give the same radius all in all again, because the center point does not change. The center does not change. Center would remain the same at the like whatever the center was in that axis, okay. Center remains the same, okay. Understand that one thing, okay.
Hmm.
Now again, whenever we are considering the radius, it will be from that point to the surface of that sphere. Okay. Now see here as well, we are seeing that particular circle which has the same center. Okay. So that means the radius will also remain the same. Understand my point? What I am trying to make here.
Yes.
See, this is the particular axis of that sphere. Okay. This is the axis of that sphere, and this is the axis for that like what can I say, surface area of the base of the cylinder, you could say it as well. So why is it difficult to understand? Because we are like drawing an 3D object, drawing a 3D object in 2D surface. That is why it gets difficult. Okay. All right. So the pi r squared h and 1 by half of 4 by 3 pi r cube. So you will do in that. Okay. Let's see what are the questions that are given. Okay, how many questions are there? Oh my gosh, 20. Okay, let's see. I'll keep on giving homeworks.
He puts it. Oh, give me homework. All right.
Calculate the volume of a triangular prism with length. Okay, so I'm not doing that, right? Like this is a
Yeah, please don't.
triangle.
It's way too easy. Yeah.
Giving answers correct to the nearest cubic centimeter, calculate the volume of prism that has a base area of 27. Okay, rectangular base. Okay, where is the right angle triangular base? Horizon and hypotenuse of 73 centimeter. From the side length and hypotenuse, you can calculate the height as well. Okay, and a length of 96 centimeter. Wait, what? One second, just let me draw it. Okay. If side length of 48 centimeter, hypotenuse of 76 centimeter. Okay, so side length, which is 48. I think that is what it means, and length means 73. And what was it? Hypotenuse. Okay, hypotenuse is 73, and wait, what? Right angle triangular base with one side length of 48 centimeter. A hyper. How can length
Yes.
be greater than hypotenuse? That is.
Okay, wait a second. Right angle triangle base with one side length, a hypotenuse, and a length of. Maybe it's like the height.
No, height cannot be greater than hypotenuse either. height cannot be greater than hypotenuse height. Because in
Or
case
maybe
of
it's
like,
like the full height.
okay. So yes,
So it's
48.
so
Yes,
one side it
48
would be,
multiplied by 2 is 96. Yes, that makes more sense.
yeah. Okay, cool. That'd be very scary.
Yes. All right. So say this is the cone shape. So what will be the radius for the surface area? Tell me.
48.
48. Okay. So the rest you can do.
Yeah, pi
A
r squared
height
times
of
lambda. Yeah.
1.05 meter and a trapezium-shaped base with parallel sides that are 40 centimeter long. Okay, so there is a prism which has like a triangular shaped base. So what you have to do is calculate the area of the trapezium, which is 1 upon 2 times the distance between the parallel side multiplied by the addition of the parallel sides. Okay. All right, and then
Yes.
you are given with the height as well, so multiply it with the height to get the volume of the trapezium. The gold medal pool company sells 3 types of above ground swimming pools with base shapes that are square, rectangular, circular. Use in the table to list the volumes of each type in order from largest to smallest, giving your answers in liters. Okay, fine. All right, so just calculate the volume and then the capacity from that volume by relating meters cube with liters. Okay, and then you will be able to get the answer. Okay, just that, nothing difficult. Understand my point?
Yes.
In case of circular pool, the like volume would be gotten with the formula of sphere. In case of rectangular, you will get the idea from rectangular pool. It's like the rectangular prism it was, and in case of square pool, it would be cube. Okay. So all the formulas are given in that way. You can. Oh my God, it's so detailed. Okay, let's see. A builder uses the floor plan of the house he is building to. Okay, the amount of concrete he needs to order for the foundation supporting the first. Okay, the foundation needs to go around the perimeter of the house with a width of 600 millimeter and a depth of 1050 millimeter. How many cubic meters of concrete? Tell me. I won't tell you. What should you do? Let's see.
At least 7.
Sorry.
At least 7.
At least I didn't get your point. At least what?
It's at least 7 meters. Okay.
Oh,
What
okay.
um
Yes.
so the foundation needs to go around the perimeter of the house with the width of 600 millimeters with the depth of uh-huh with
Visualize
the
it like
width.
how is your building constructed? It's not like uh, uh, just walls of no thickness at all, right? There are certain thickness of walls, okay, and also beneath the walls there is sort of foundation given, right?
Um
Think it in that way.
so like oh okay, that makes so much more sense. So there would be like around the perimeter, there'll
Yes.
be an outer perimeter of that brick of that cement. Oh, sorry,
Um,
concrete,
yes.
and then there'll be
Think.
another perimeter 600 millimeters smaller.
No, actually not like that. Okay, see, if I draw something, see, say this 6 meters. Okay, let me transform it to a three-dimensional object. Okay, 6 meters. Okay, fine. It looks like that, but actually it's much more detailed. Okay, so this 6 meter has a certain depth. How is the depth gotten? As you said, we have used bricks. Maybe we would have used concrete. Okay, in different buildings. In case of strong buildings, we use concrete. So that is the width, which is 0.6 meters or 600 millimeters. So it would look something like this. Okay. If you
Yes.
would have examined any construction site at the beginning stage, you would see it looks like this. Now, does it end here? The answer is no, because a particular room has a ceiling height, right? It is not like it does not
Yes.
end at the surface. Okay, so that is what they're saying. It has a depth of 1050 millimeter. Depth by depth, that means it's a height. Okay, so it would look something like this. Okay, say if I draw it. Okay, so all right. So now this and this. Okay, so this is how with say obviously not one wall, say four, say 10 walls, 20 walls, like that way a building is constructed. But what I'm trying to make you understand is that whenever a wall is constructed, it has a certain sort of thickness which they are considering as width. This is the thickness of the wall. Okay, this is the thickness. All right, and the depth of 1050 millimeters, which is the height. Now the width is given, the height is given, and obviously you can see the length of the all the walls. So how does this wall now act like? It acts like a three-dimensional object and as a rectangular prism, as we understood, right? Because the two of the sides are same or similar looking. Understand up until now?
Mm,
Okay.
I
So
think
now what should you do next then? What should you do next then?
at least 7.
Yes, at least 7. Okay, see, the foundation needs to go around the perimeter of the house. Okay, perimeter of the house. Now, what is the perimeter? What we understand is the perimeter is the boundary. Okay, so now we will not consider these walls which are inside the house. Okay, okay, because whenever we are constructing the inner walls, okay, that I mean there are less concretes involved because they are not like they don't take the direct load of that building. Okay, so that is why we won't consider that portion at least for this math. Obviously concretes are needed in this case, but the walls are less thick. Okay, if the outer walls are 0.6 meters, the inner walls might be 0.3 meters or 0.2 meters. Okay, so we are not considering the foundation in this case for the inner walls. Just consider the outer walls or walls in the perimeters. Okay, so they will be neglected. Okay, so now in which scenarios are we considering the foundation or the concrete to be put in? It is in the case of the outer boundaries. Okay, so first add these values, which is 8 meter plus 7 meter plus 1 meter plus 6 meter plus 3 meter plus 9 meter.
Which would be 39, I think.
Okay, so it could be, let me calculate, 9876, which is 17, 24, 30, 34, 34 meters. Okay,
But what about the other length?
which length?
Like the unknown.
Which unknown?
So it's
This is
between the 6 meters and the 1 meter.
between. Oh, okay, okay, okay. All right. Yes, yes, yes. You are correct. But I have to calculate. Okay, so 9 minus 7, that will be 2. This is 2 meters.
Plus 3 would be 5, so 39.
Okay, very, very good spot. Okay, all right. I didn't see that. Yeah, there was another one. Okay, so now 39 meters. Okay, now 39 meters are the all lengths of the rectangular prisms. Okay, so now you can add them and multiply with the same width and same depth. Why can we do that? Because
Because why not?
if you see, say 9 plus, say for instance, for one case, 9 into 600 upon 1000 upon, sorry, multiplied by 1050 upon 1000. Okay. And in this way, these two values will remain same. And what will change is just the values for um, the lengths. Like it will change to 1, it will change to 7, it will change to 3, it will change to 6, and so on, so on. So we are taking these two as common and adding all of this together to get 39. Okay. So then you will get the
Okay,
answer. Understand my point?
I understand.
So it was a good math. And the builder also wants to order concrete required to pour a rectangular slab 3 meter by 4 meter to a depth of. Okay, I mean, it, this
That's
is
pretty
just.
easy. Yeah.
Yes, that's easy. Okay, okay. Giving answers correct to the nearest cubic centimeters, calculate the volume of a cylinder of radius. Okay. Hence, calculates capacity rounding to the nearest milliliter. So just centimeter, convert it to milliliter. Nothing else. Okay.
Yeah.
The amount of centimeter cubes is equals to amount of milliliter. Okay. I saw. Okay. Why is it hyperlinked to this point? Like the watt example 12. Like they are similar. Something like that, right? I think so.
Yeah.
Okay, calculate the volume of a cylinder that has a base circumference of 314 centimeter and a height of 0.625 meter. Okay, giving our answer correct to the nearest. Okay, so from the base circumference, you will calculate the radius, and the others are just like calculating volume. Okay, all right.
Yes.
Okay, again, this is easy as well. A company manufactures skylights in the shape of a cylinder with a hemispherical lid. Okay, fine. When they are like it's like the as I say in case of the masjids we design. Okay,
Yes, the masjid.
okay, right. So when they are fitted under a house, 3/4 of the length of the cylinder is below the roof. 3/4 of the length of the cylinder is below the roof. Okay, fine. If the cylinder is 1.5 meter long and has a radius of 30 centimeters, calculate the volume of the skylight that is above the roof and the volume that is below it. Okay. So what you are going to do is just like draw a hypothetical sketch. Okay. Like exact sketch, okay, with the values given. Okay. So what are the dimensions? 30 centimeter is the radius and 1.5 meter long. Let us first draw the cylinder. Okay. So it will be something like 30 meters. That is radius of 30 centimeter. That is 30 centimeter. And it is long of 1.5 meters. Okay, fine. Now, when they're fitted onto 3/4 of the length of the cylinder is below the roof. Okay. So now 3/4. Okay, 3/4. That means 1.5 multiplied by 3 upon 4. Okay. So you will get a particular value. Okay. And then you will also get a value for 1.5 upon 1 upon 4. So what the value you get for 1.5 times 1 upon 4. Okay. That is of which shape? That is of hemispherical shape. Okay. That is what it says, right? Okay. Yes. Okay. So it will look something like this. Okay. Understand my point?
Yes.
And based on that, you all obviously got the radius, and based on that, you can get the other values as well. Okay. So uh, I hope it's understandable, right? So I'm not getting like in detail.
No, it is understandable.
All right. But if you find it difficult, because as I am saying from the very beginning of our standard 11 or 12, you should complete this whole book. Whatever assignments you are doing, and no matter how much exams you give, it's really necessary that from now on, as the syllabus is very broad, you should complete this book, okay, at least once. In our time, we
Okay.
completed our book, say, 3 4 times maybe, or maybe some students even more times. Okay.
How would you do the same question 3 times?
I
Why?
mean, not the same question actually. Say, for instance, first time you will do it in detail, okay. But whenever you will go, I mean, say after 3 or 4 months, you are trying some maths, or say in physics or chemistry, you will see that there are certain things you have forgotten. Okay. So now you will check from the get-go. Okay. So number one, okay, I see it's understandable. I can do it easily. Okay, I'm skipping it. Okay. But by doing so, you are also setting some like some sort of message to your brain that okay, I understand that, I am confident that I can do it in the examination hall. That is why I'm skipping. Okay. In that way, say for instance, this math. Okay. There is high chance that you might forget it after, say for instance, 5 or 6 months. Okay. and you will just revise it. That is what I mean by completing the book 4 or 5 times. Okay, I am not saying that
Yeah.
doing everything over and over again. But in case of certain topics, we actually did things over and over again. Like some topics in mathematics, like differentiation, integration. I will guarantee you that anyone who is like very good at integrations has spent hours and hours long lifetime to be better at that. It is such a difficult thing, the integration part. Differentiation, you
Mm.
might be good by doing 2 or 3 times, but for being better at integration, you have to do it 6 or 7 times. Okay,
Oh no.
it's that much difficult. I'm just giving you like hypothetical examples. It might, I
Yeah.
mean, by 6 or 7 times, I'm not meaning like exactly 6 or 7 times. Okay,
Yeah. It's just
because
yeah.
what happens is, whenever the examination occurs, it's a time bound. Okay. Say, for instance, when we would give a board examination, we would get like 10 minutes to solve a particular question. But when we would sit for university examinations, we get only 3 minutes to solve that particular question. Only 3 minutes, which is 1/3 of that time. And also the amount of page we can use, that is also like there's a constraint of space. Now, why is it so? You might ask that why don't they give like extra pages? Because the thing we will do in the latter period of life, which is engineering, okay, here we have to work with like say for instance less amount of time, like a project cannot go on with like say 3 or 4 years, which is to be done within 1 year. And also we have to find the most economic and efficient way to do that particular project. Say for instance you are building a building, okay. Say for instance if you say give 5,000 to 6,000 tons of concrete instead of 1,000 tons, obviously that would be stronger, and that would have lesser chance to uh, be like
Break.
resistive to uh, earthquakes or maybe storms and all. But
Mm.
that is not the idea of an engineer. The engineer would find the most efficient way to make it cost effective. Okay. Otherwise, there is no need for engineering as well. Okay. Anyone
Mm.
say, architectural beauty, that is another thing. Like you would try to ornament a building or something like that. Okay. So getting back to my point, so that is why doing mathematics is one thing, and doing mathematics quickly and in an efficient way is another. Okay, whenever you will do the same thing over and over again, there will be lesser possibilities that you make a mistake at all. Okay. Whenever you are doing assignments, you are like, okay, let me check it by doing it in the calculator, let me check it in the internet. You will not get that much time to like is the calculator twice or 3 times. So you would be need to efficient in that as well. So these are all the things that are involved in like preparing for an examination. I'm not saying that if one does not complete the book 6 or 7 times, he or she will get bad at that particular subject. I'm not saying that. Deep down in his or her brain, they know what they have been taught previously, and they might revise it to get the understanding. But without exercising like for a vast amount of time, it might get difficult. I'm not saying, I've seen students who don't do that much of math and they do pretty well, but the portion is very less. Okay, because by born talent like those students, they come in 1,000 maybe. Okay,
Mm.
and even they have, I've seen they have struggled in instances, like they have mistaken in the calculations. Okay, or they have like gotten less marks than they were expected to. Say, for instance, my one friend, he was in board examination, he stood 237. Okay, he was expected to be in the like in Bangladesh, he was expected to be at least among 1 to 50. Okay, so why did he get to 237? Because there was less amount of practice. Okay, nothing else. There was no particular reason for it. And there are like various students who are not that much of talented. Okay, but they practice so much that they increase their level to a lot higher level. Okay, so By birth skill or by birth talent, yes, that is a blessing to have. And Allah has blessed everyone in every certain way, like different ways maybe. Okay. But one thing we can control is our efforts. Okay. That is the thing that is within our control. I might be dead the next day. You might be dead the next day. We don't know that. What will happen to us in like 7 days' time? We don't know that. We are not prophets, right? We don't know what is going to be in the future. Just the effort, that is what is in our hands. Okay. And that is what keeps us satisfied, that okay, I have put enough effort and I have tried enough, but okay, it has not happened. Maybe in the latter life I will get something better. That is what is in our hands. Actually, if you truly see life in the simplest of way, that is it. Okay. There is I don't know if you have heard of Kaji Nazrul Islam. He's our national poet. He wrote something, if I translate it, it was something like that. He's like in a satirical way, you could say. He's saying that what is the like need of creating that universe? He's saying to the God. Okay. And he's saying that you are like playing with us, like children plays with their toys. Okay. This universe is your whole toy and you are playing with it. Okay. That is the thing. See, if you like try to find the answer that why was this universe created, why was human beings created, at the certain level, if you study like religious books and all, at a certain level you will be able to understand that. But after that level, you have limitations to think. Okay. That is how helpless we are as human beings. Okay. And also another thing, think about it. The I mean, Allah has created the whole universe. He is, I mean, aware of whatever is going to happen in the future. Okay. Okay. Maybe you would say, ask that, okay, so if everything is defined, what can we do? So Allah has given us just one thing, just one thing. That is the freedom of thinking, nothing else. Okay. We are controlled by the devil to do bad things. Okay. So it's just like a fight. It's just like a fight, like between the goods and the bads. So why do we pray? We pray to seek forgiveness, obviously, and also to to Allah, that we don't get deviated and we stay at the right path, because that is the only way we could fight with the devil. Okay. That is how helpless we are as human beings. Okay. That is the simplest meaning of life. Like whatever we are doing, we are becoming scientists, and we are becoming doctors and engineers, but at the end part we are getting buried in that say 5 feet deep ground, right?
Mm.
All right, enough philosophy.
Some good wisdom for today.
All
Good
right, so
wisdom.
where were we? Okay, let's see, at least complete till 10. Okay. Yes.
Okay.
So the outer shape of a washing machine is a rectangular prism with a height of 850 millimeters, a width of 595 millimeters, and a depth of 525 millimeters. Inside the machine, clothes are washed in a cylindrical stainless steel drum that has a diameter of 300 millimeters. Okay. Right now, we determine the maximum volume of water in liters that the stainless steel drum can hold. So dimensions are given. You have to calculate the volume of that cylinder. But see, you will get the volume in millimeter cube. Okay, you have to convert it to centimeter cube. So then you can change it to milliliters. Okay. Otherwise, the answer. So how can you convert it to centimeter cube? Tell me. Yes.
Times it by 10.
No. How can you
Sorry,
convert?
divided by 10. No, wait, no.
Divided by 10 cube, because there are dimension in 3 millimeter scopes. Okay.
No, that's true.
Right. So 10 times 10 times 10. Okay. That is how you will divide. Okay. Right. Calculate the volume of the washing machine in cubic meters after subtracting the volume of the stainless steel. Okay. So very easy. Nothing difficult. Calculate the volume of a cone of radius 30 centimeter, height of 42 centimeter, correct to one decimal place. Okay. This is also easy. calculate the volume of a cone that has a base circumference of 6 to 8 centimeters and a height of 0.72 centimeters. Correct
Okay, that's
to
easy.
the next. Okay, so this is also easy. A height of 30.36 centimeters. Okay, okay, fine. You will be able to do that. This one as well. So this is not difficult. And from 11 to 20, we will do the in the next day. I hope it won't take much time. As I see, there are if the images are given, the interpretation of the maths of three-dimensional becomes really easy. Okay, but whenever like if they were like linguistic things saying that say these sort of things, if they were seeing it in a linguistic way, the maths would have gotten like 10 times more difficult. Okay, so inshallah we could, I mean, finish this chapter in the next day. Okay, so now my question is, okay, what happened? Why is it taking so much? Am I with you? Okay, all right. Yeah, I have been logged out. Wow. Can you hear me? I don't
I can hear you. Yes.
know. So inshallah we will complete this chapter the next day. Okay. Okay. Is there another chapter? Okay. Oh no. Actually, or did we? No, we did not do this. Okay. So that chapter was particularly for volumes, and this one would be for surface area. Okay, so I think we will need 2 days more time. Okay, no worries. But the one chapter we have started, we should end it properly. Okay. Now, I think after that you should be able to do the exam practice properly. So see, the chapter is like really fast, so you have to practice it. The previous chapter was very easy. The one that was like consumer arithmetic. So these ones are easy. So
Mm.
I think we should particularly focus on the difficult topics because obviously all of them would be taught in your school as well. Okay, so we should, I mean, focus on the difficult topics. Okay. All right. So
Mm.
your homeworks are already given. I have already talked about them while taking the class,
Yeah.
and you will just let me know what chapter should we start next. It could be from elementary maths, it could be from general maths, or it could be from special maths. Okay. So just let me
Uh,
know.
I feel like I probably need some help on specialist maths
Okay. Special maths. Which
because
chapter?
right now, okay, it's so weird because my teacher kind of simplified it down to, okay, first thing we're gonna do is counting. We're gonna learn how to count. And then the next thing, he
Okay.
said, okay, we're gonna learn how to read. Okay?
Okay. Okay.
Sounds simple, right? But before we were counting using set theory
Yes.
and combinations and permutations.
Yes.
And now I'm now learning a different language. It's called math. I'll send you a picture of what
Okay.
the symbols are, but
Isn't
it's
this the
scary.
chapter?
Yes, that is the chapter.
Okay. I'm not seeing anything like out of the ordinary. Let's see if I can get it. Okay. Counting techniques ends here, like factorials and. Oh, okay. Factorials. This is what you are saying. Like,
Yes, factorials and
oh,
permutations and
all right.
combinations and
This is,
etc. etc.
I would tell you, this is one of the hardest things to learn and one of
It
the
is,
hardest things to teach in mathematics. Yes, this is really hard.
especially with restrictions and everything.
Okay, I will try to teach you from, I was blessed to get instructed by a very great teacher. Okay,
Blessed with the
I
power
might
of
not be
math.
that great, but I was lucky. So I have
Yeah,
class notes of
I
his
believe in you.
up until now.
Yeah,
So I will try
I
to
believe in you.
give
Yeah.
whatever I have. Okay, all right. So okay, all right, no worries. Okay, so permutation combination is yes, so
And
very
then Pascal's
interesting. But
triangle and
yes,
pigeonhole principle.
Pascal's triangle is easy. You have, I
And
think.
then yeah, Pascal's triangle is easy, but pigeonhole principle is a bit harder
Okay,
by just getting your
which
head
okay,
around it.
one second. Pigeonhole principle. Let's see. I don't think I have read that. What is pigeonhole
Oh, so
principle?
yeah, that formula. If you go up a little bit,
Mm-hmm.
so
Okay, yeah.
there.
First one, pigeons to be replaced in pigeonholes. Then there is at least one pigeonhole with at least what?
So okay, so say for example you have
Hmm.
um six pigeonholes, right?
Right.
Or six pieces of chocolate.
Mm-hmm.
Okay, no, say that okay, scratch out everything. Say that you had six people
Yes.
and you want to share chocolate to, and you have seven pieces of chocolate and you're not
Right.
sharing, yeah, and you're not getting one, then
Mm-hmm.
there is at least two people sorry, there are at least one person
Hmm.
with two chocolates.
Okay, so it's like more like degrees of freedom, more than like pigeonhole principle.
Sort
Uh,
of, sort of.
right? Yes, the degrees of
Yeah.
freedom. Say for instance, you have say for instance seven hats. Okay, seven hats, right? And you have
Yes.
decided to use one of them each day of the week. Okay, so for the first day, you can choose between seven. Okay, fine. So one is out. Now, in the second day, you have options as well. Third day, you have option as well. In the fourth day, you have also options. In the fifth day, also. In the sixth day, also. But in the seventh day, you don't have any freedom of choice. In the seventh day, you have to wear the one hat that is left. Okay. So I think it's kind of related like that. I don't know if it is like that, but I will read about the pigeonhole principle a bit more in detail. So I think it's sort of related with the degrees of freedom. Okay. All right. No worries. I will check about that. So we will start after completing that three-dimensional thing. We will start combination and permutation. Okay. All right.
Yes.
Yeah. All right.
All right.
So Allah Hafiz for today. I've taken a lot of
I love.
time of you.
Oh, when
Oh
is our
yes, yes,
next lesson?
yes. Are you free
Because
tomorrow?
I'm gonna be at the cricket game tomorrow.
Oh, okay. So it's between Australia. No, actually, there is
And
no.
Australia, no, Bangladesh and South Africa.
No,
No, wait, no.
Bangladesh and Zimbabwe.
Zimbabwe. Zimbabwe's in South Africa, right?
Zimbabwe is in the continent of Africa. I don't know it's
Okay.
because South Africa is another nation. I don't know if Zimbabwe is in the
Really?
south side or yes, South Africa is a nation and Bangladesh lost to South Africa by 104 runs. Okay,
Ooh, that's cool.
all right. Oh,
Okay.
very good. Very
Um,
nice to know that. Okay, I hope you can
um,
see Bangladesh winning. So okay, the day after tomorrow.
a day after tomorrow, I'll see, because next week will be just packed with different stuff. Because Thursday I won't be available.
Mhm.
Wednesday I won't be available.
So I
Saturday I won't
think
be
we
available.
should be
Yeah.
we should do Monday then. Monday
Yeah, let's
anytime.
see Monday. Yes,
At what
let's see
time?
Monday and see. I finish at 1, so we can do
So
3 slash
11 a.m.
11
right? 11. Okay, all
yeah,
right.
11 a.m. Yes.
Okay, all right. Okay. See you then.
Okay. See you
Okay.
then. I love this. Wish Bangladesh luck.
Yes.